I welcome all of you once again to the part 4 of model building. So let's get started. Let's see the skills we will cover in today's lecture. First of all, we will make a basic understanding of logistic regression, and then we will see its working. In the last, we will see the evaluation of logistic regression. So what is actually a logistic regression in R? Logistic regression is a statistical method used for binary classification problems where the goal is to predict one of two possible outcomes based on a set of independent variables. In other words, it's used to model a binary dependent variable such as success, failure, yes or no, or true or false. It's a powerful tool for analyzing relationships between variables and is widely used in fields such as marketing, finance, and medicine, among others. So, what are the advantages of logistic regression? A simple and intuitive model that is easy to interpret. Logistic regression can handle categorical predictors capable of handling large datasets and can be used for large-scale logistic regression analysis. It can handle nonlinear relationships between the independent variables and the dependent variable. Many flexibility and customization options allowing you to modify the model specifications and estimation methods. So now it's time to see the disadvantages of logistic regression. Limited in its ability to model time to event outcomes, which I will explain later in this lecture. It can become computationally expensive and unstable when applied to high-dimensional datasets. It can be prone to overfitting, especially if there are many independent variables or if the sample size is small. So, how logistic regression works? Logistic regression works by using a logistic function. Here's how logistic regression works in general. The dependent variable and independent variables are specified in a statistical model. Then the logistic function is used to model the relationship between the independent variables and the dependent variable. Then the logistic function transforms the output of the model into a probability value between 0 and 1. Then we have a threshold that is applied to the probability value to transform it into a binary prediction, such as true or false. This threshold is typically set at 0.5, but it can be adjusted. Then the model parameters, or you can say coefficients, are estimated to maximize the likelihood of observing the data given the model. Now, here's an important note to consider. Once the model is fit, it can be used to make predictions for new data. The independent variables for the new data are input to the logistic function to obtain a predicted probability, which is then transformed into a binary prediction using the threshold. And you can also evaluate your model using various statistical measures. So what is the syntax for logistic regression? Here is the basic syntax for creating a logistic regression model in R using the GLM function. Let's see. Just use the GLM keyword, pass the formula, then the dataset and some other parameters, where formula specifies the dependent and independent model. The dataset is the name of your data frame, as you know. Family argument is to indicate that this is a logistic regression model. Now let's move to our studio for a hands-on session. Now, first of all, I have a dataset with the name of empty cars. So that's it. You can see some columns here. But before using the logistic regression model, I will do some changes in this dataset. Let's say I create a new dataset with the name of car DF, and I say that take the empty cars dataset and take all the rows. Now by using the combine function, I say take only the columns of VS and MPG and cylinders and displacement, horsepower, and in the last weight. Now what I want to do is to predict this VS column that contains the value of 0 and 1 with the help of logistic regression. All right, so let's say car DF. Let's run it. Well, that's pretty good. All right, so now let's create a logistic regression model. I will say log model, and inside this variable, I will use the function of GLM to create a logistic regression model. And what I want to do is to predict the VS, and I say take only the cylinder as the independent variable for the prediction, and here data equals to car DF. And in the last, I will pass the parameter of family equals to binomial. All right. And here let's say log model to see the details of our model. All right. Now let's generate a summary of this logistic regression model because I want to know more details about this model, such as quantiles, as you can see here, and the p-value for cylinder is smaller than 0.5. That means that this cylinder variable or feature or column is quite important for predicting the VS value. All right, so this was an example of simple or single logistic regression model. Now I will create a multiple logistic regression model. I will say log model 2. And here I will use the function of GLM. And I say I want to predict VS. And here I say take MPG for prediction and cylinder as cell. And this time I will also pass other variables such as displacement, horsepower, and weight, and take the dataset of car DF, and family would be the same. It would be binomial because we're predicting a binomial distribution. And here I will say log model 2. And let's create a summary of this model. All right. Now you can see that the values are below than 0.5 for all of these columns. That means they all are significant for predicting VS. And here you can see the quantiles and other details as well. Now let's move forward. This time I want to make a prediction, but I will split the dataset into training and testing parts. So let's do it. So first of all, I will say library and then say tools, and let's do the splitting. I will say split, and inside this variable, I will use the function of sample.split, and here I will pass the data frame of cars DF. But now first, let's create a new data frame. And for instance, this time I want to do something different. I say cos df2, and I take the aim variable instead of width and cos df2. All right. Great. So here I pass the data frame. I say take this data frame and the split ratio should be 0.8. It means that 80% of my dataset will be used for the training and the rest of the 20% will be used for the testing or the prediction purpose. So at first I will say train df, and inside that I say subset and take this data frame and split equals to true. And similarly, I will say test df, and I say subset, take this data frame and split equals to false. All right. And here I say log model free, and I say GLM. And first of all, I say what I want to predict is AM, and take all of the other independent variables for the prediction. And here I say data equals to, and this time I pass the training data, train df. All right, and family equals to binomial. Here I say summary and logistic regression model 3. Let's run it. That's good. All right. Now let's do the prediction. I say warpred, and here I use the predict function. I say take this model, and the new data should be test df. All right, and type equals to response, and in the last I will just change the probabilities. I will say warpred equals to, I use if else, and I will say if warpred is greater than 0.5, then the value is 1, else the value should be 0. Let's run it. All right. And here, let's do the evaluation. I will say test df and take this m column and take the warpred. All right. So here you can see that the correct predictions for predicting the value of AM0 is 19, and there is no wrong prediction for predicting 0. And the same goes for 1. We have correct predictions of 1, 13, and 0 wrong predictions for 1. Now, you can also use some other evaluation metrics to see the performance of your logistic regression or any other machine learning model, but we will see that in the next video. Now let's get back to slides. So here's what we have learned today. What is logistic regression? What are the advantages and disadvantages? And how logistic regression works. And in the last, we have seen the evaluation of logistic regression. You can also use logistic regression for predicting or doing a regression task rather than classification. So here's your homework. You have to clean the data set and the link of the dataset is available here, and build a logistic regression model, and in the last do the evaluation. Now good luck, see you next time.